We have created ground images that alter the depth perception and speed perception of mid-air images. Mid-air imaging technology can display a variety of images in 3D space and allows interaction with the images. A micromirror array plate, MMAP, forms a mid-air image at a plane symmetrical position with the light source. One of the characteristics of mid-air images is that they can be placed together with real objects. However, viewers have difficulty perceiving the depth of mid-air images than the depth of real objects. To solve this problem, using a 3D display as a light source can add depth to a mid-air image. However, the performance of the binocular parallax limits depth. Another characteristic of mid-air images is that they can move in 3D space by moving the light source. However, when a fast-moving mid-air image is displayed, it quickly becomes invisible due to its limited display area. Therefore, in content that uses mid-air images, there is a limit to the speed at which the mid-air images can move. Therefore, we investigated whether presenting an image directly below the mid-air image would affect its perceived depth range and movement speed. Specifically, two types of changes are confirmed by psychophysical experiments: changes in perceived depth due to shadow projection with different lengths, and changes in perceived speed due to motion contrast between a mid-air image and the ground. Our contribution is that using this study's findings will make it easier to design mid-air image contents, because it can extend the perceptual range for depth and speed. The purpose of this experiment was to determine how varying the length of a shadow under a mid-air image affects depth perception. Participants compared the depth of the reference mid-air image with a shadow and the comparison mid-air image without a shadow. The participants then chose which of the two mid-air images had greater depth than the mid-air image itself. We calculated a point of subjective equality for perceived depth. This point indicates how much the depth, 5.0 centimeters, of the mid-air image with a shadow of a certain length was perceived as depth. This graph shows that as the depth of the shadow increases or decreases, the perceived depth of the mid-air image that matches it also increases or decreases. This experiment investigated how the perceived mid-air image motion is changed by the motion contrast. In each trial, the participant first saw a reference stimulus moving over a scrolling background. After the reference stimulus disappeared, the participants had to adjust the speed of the comparison stimulus to match the speed of the reference stimulus. This graph shows adjusted speed of the comparison stimulus for each ground speed. Perceived speeds when the ground moved in the opposite direction relative to the mid-air image were 58% higher than those when the ground moved in the same direction. In this study, we placed the ground below a mid-air image and investigated how changing the ground image affected the perception of the mid-air image.